Chapter 5, the operational amplifier, also called the op-amp. An op-amp is a voltage-controlled voltage source, and this is called the micro amplifier 741. It was first invented in 1968, and we would say that it's a voltage differential input voltage amplifier. Op-amps are integrated circuits that are used as elements in more complicated integrated circuits. So we have a symbol for the voltage-controlled voltage source. So our symbol for the voltage-controlled voltage source changes for op-amps. And this is what we know. We know that our standard language for a voltage-controlled voltage source is that our voltage source we call Vs. There's some type of constant, a gain, and then we have some controlling element. And typically, that element is a resistor many of the times. But this would then be V control across this element, where I'm going to say that we have that. So if I look at the language that we're going to be looking at, this is going to be V out. And then we're going to have AVN. And so what you're seeing in this situation is that we have an output and we have an input. That input is the voltage differential that we'll talk about here in a moment. So what does the new symbol look like? So the new symbol for this op-amp now reads like this. We're going to have an input, and it takes on this triangular shape. And what you're seeing here is that this is the negative and this is the positive. And between these two nodes is where the input is at. And then now this is V output. So this is our new symbol for the amplifier. But remember, it's still a voltage-controlled voltage source. So what we need to do here is that we need to talk about language. So let's look at the nomenclature. So if I look at the nomenclature, I'm going to have a long wire because I want to separate it from V2. So here's my op-amp. And I think I'm going to move this down because I'm going to run out of space. I'm going to need to bring this up a little bit higher. Then I have V out right here. And so what we have is that we're going to call that V1. We're going to call this V2. And so everything that we see here is measured relative to the ground. So let's say that we have a ground that goes all the way across here. So these are not voltages, they're node voltages. And so if I look at that, when I talk about V1, that means that I'm measuring the voltage across here. So this is the voltage V1. And of course, this is the voltage V2. And then this from here to here relative to the ground is V out. So what's Vn? Vn is the difference between these two right here. That is Vn. So then the language goes and it does this. This guy right here, this is called the inverting input. This guy right here is called the non-inverting input. And you can see the science is telling you what that is. And one of the most important things about an op-amp is that there's this feedback line. And this line here is called, this guy is the negative feedback line. Now, I want to make some remarks. So again, I'm going to move this over here. And let's add some of the things that we need to add. One, we have the controlling voltage. We've already written this. This is called Vn, and this is the difference between V1 minus V2, or V2 minus V1. The other thing that we should look at is that the voltage-controlled voltage source, that is, this is our voltage source, is called V out, and it's equal to the gain times Vn. And a possible range of the gain is the gain of Vn. It goes from negative 100,000 to positive 100,000. So that's a pretty hefty gain. Now, in order to amplify any voltage, one must supply energy to the op amp. Otherwise, magic occurs. You can't get energy from nothing. So one violates if you don't put energy into it. So in our case, there are two separate voltage source inputs. And typically what they are, they're set at plus and minus 15 volts. So these guys are supplying the energy to the thing. So let's now look at the wiring details. Oops. So let me bring this up. And so here's what I'm going to do. I have an image that I want to share with you. This is the pin configuration of the op amp. And what you're seeing is that there are 8 pins. And you could see that pin 4 and pin 7 is where you add the negative and positive 15 volts. So once again, pins 4 and 7 are the supply input sources. So when we draw an op amp, okay, so when we draw an op amp, you should always remember that the op amp with its input sources really looks like this. So we have this guy right here. So we have pin V1, V2, and then of course we have our output. And as we said before, everything is measured relative to the ground. So when you look at pin 4 is drawn in such a way that the positive is connected to the ground. So this becomes our negative supply voltage. Pin 7, which is up here, that becomes this guy. And this is our positive supply voltage. But it's customary to not put those in. They're there, but it's customary to not put them in. A typical sketch of the op amp does not include the plus or minus 15 volts supplies. However, they are still there. They are always assumed to be there. So how do we typically draw the op amp? So when we draw the op amp, it's going to look like this. I'm going to copy this. Now I'm just going to edit it. we're going to take this guy and we're then going to come in and we're going to say, yep, it actually looks like this. So this is V1, this is V2. Here's our output. And it looks like that. That's our output for the op amp.